Okay, so in this problem, we're told that the volume of the cone in the drawing at the right, or well, here, down here, is 1/3 28 times pi. So 1/3 times 28 times pi. They want to know what are some possible radius and height measurements for the cone. Okay, so the radius, of course, they point out here in the dotted line, and they're referring to the radius up here as if the cone fit into a cylinder, because the nice thing about a cone is that it's exactly 1/3 of the area of a cylinder with equal base and height, right? So if you knew the volume of, not 1/3 of the area, 1/3 of the volume of the cylinder of equal base and height, if you knew the volume of the cylinder, right, then we divide it by 3 and get the volume of the cone. So they're trying to remind us they're trying to tell us that here. Also, it's just neater, right? It points out really the radius and the cone is referring to this line down here, which is the same as this one above, but the circle here is on the bottom of the cone or the base. And the height, of course, is the height of the cone from top point to bottom, just as it would be for a cylinder. So what do we do? Well, the volume of a cylinder is my starting point, because like I just said, if you take the volume of a cylinder and divide it by 3, you do get the volume of a cone. And a cylinder is a very logical shape to think about because it's just the area of a circle. Pi r squared, right, that's the base of the cylinder, or the area of a circle at the base, times the height. As if you had like x number of circles with a height of 1 stacked across a height. Wow, I said that really badly. Let me say that again. You multiply it by the height, right? Because you're saying, okay, take this circle on the bottom and stretch it across this height h right here. And of course, the circle is flat to begin with, but when you stretch it over a height, you're assuming it has some unit rate to begin with, maybe like a height of 1, and that is what you're stretching or decreasing depending on the height of the cylinder. Anyway, what this really means, I'm botching this up, sorry, but you have the area of a circle times the height. It's like stacks of the circle over and over again that fill the volume of the cylinder, right? That's what's happening, circle times height. And then the cone is just 1/3 of that. So the volume of the cone is equal to 1/3 pi r squared h. Okay, so here you can see in the formula what we're given for this cone, right? In this case, the cone, the volume of the cone is equal to 1/3 28 pi. Now we know that the cone 1/3 28 pi is equal to 1/3 pi r squared h. That's the definition for the volume of a cone, right? So here, if we're trying to solve for different radiuses and heights, so how would we do that? Well, I'd multiply everything by 3 to get rid of the thirds, right? So multiply by 3 right across. On the left-hand side, that'll cancel the third right out, so we get 28 pi. And here on the right, it'll also cancel out the third, so we now just have pi r squared h. But I don't want to deal with pi, I want to figure out r and h. So I divide by pi on both sides. So now the pi's cancel out. And what we have here now is what? Well, 28 is equal to r squared h, right? Those pi's canceled out. And this is just saying that you're looking for combinations of r squared and h that equal 28. So how do we do that? Well, first let's solve in terms of r squared. Right? Let's think of it that way. So r squared equals 28 over h. All I did there was divide both sides by h. And then if I take the square root to solve for r, then r is equal to the square root of 28 over the square root of h. So that it'll follow this pattern. We can also solve for h in terms of r. We can divide by r squared on both sides, so 28 over r squared, that equals h as well. So algebraically, we can think of it in that way. What I'm going to do is just think about it, because they don't ask for a complete list here, I'm just going to kind of build this pattern up. I know that whatever these two numbers are, they have to multiply to give us 28. So r squared times h equals 28. Well, if h is, let's say, 7, right? There's a factor of 28. What does r squared have to equal? R squared times 7 equals 28. Well, we know we're going to end up using this formula right here, solving for h. Oops, sorry for solving for r. We're using this formula right here. essentially what we're going to have to do now is r squared will equal what? Well, times 7 equals 28, so 28 divided by 7, right? So that's what we're doing here, 28 divided by h, and that equals 4, but then r is equal to the square root of that, right, of that whole quotient, so that equals 2. So really, you're just dividing 28 by h and then taking the square root of that to find the value of r. So one possible pair, h could be equal to 7, right, and r could be equal to 2. But there are other factors, right, and we can keep going with this. H could be 14, right? It's also a factor of 28. So 14 times what squared is equal to 28. Well, again, we solve the same way. R squared equals 28 over 14, which equals 2. Take the square root of that, and r is equal to the square root of 2. So now, in this case, what happens is that h is equal to what? Well, 28, and r is equal to the square root of 2. And we can keep going, right? There's no limit here. Now, we chose two nice factors of 28, but really we can choose any number here just for fun, right? Let's say h is equal to, I don't know, 20, right? So 20, right? What squared times 20 equals 28? Well, again, we go through the same exact process. R squared equals 28 over 20. We can reduce this to 14 over 10, which equals 7/5. And then what? Well, r is equal to the square root of 7/5. So here, in this case, h is equal to 20, and r is equal to the square root of 7/5. So you can play with this and really pick any number for one, and then just solve for the other variable. In each case, I've chosen h, right, and then solved for an r. You could have chosen an r and solved for h using this approach right here, right? 28 divided by your r value squared. And you can generate this list and keep going. That's the basic idea relating the cone and the cylinder to find the radius and height. All right, hope this helped.